So hi everyone. Today we are going to solve the problem kth largest element in a stream. So this question has been asked in the interview of Amazon, Google, Adobe. You can see the companies here. So first of all, let's go through the problem. So design a class to find the kth largest element in a stream. Kth largest element in the sorted or not the kth distinct element. Okay, initialize the object. So let me show the question. So we are given two functions. Like one is the constructor initializes the object with integer k and the stream of integer nums, int, and a function int add appends the integer value to the string. So let me show the code. So here we are given a constructor of name kth largest that takes the input of k, that we have to return kth element, the value of k and the num stream, and also we have to complete a function add. So the requirement here is, for a in the constructor we have to initialize a data structure. We have to decide on the data structure which we are going to create. So and also in the add function we have to add the given value to the data structure and return the kth largest element whenever we add a certain number at that particular time. So to do this optimally, let's understand through example. So first of all, let me go to the drawing board. Okay, so we are given, here we are given, initially we are given k value equal to 3, and array is 4 comma 5 comma 8 comma 2. So we are initializing the nums array here, and the k value is 3, and the next operation is we are adding 3 to the array. We are adding 3 to the array. So now, after adding 3 we have to return the kth largest element. So the k value is 3, third largest element. To get the third largest element, let me short this array. 2 3 4 5 8. So this is the first largest, second largest, third largest. So third largest element is 4. So the first brute force approach which we can get here is, so every time we are, first of all, at the initialization step, we simply have to sort the array, the nums array, and then every time we add the element, we have to find the correct spot. Like this is the sorted array as of now, and next one we are going to add 5 to it. So to add 5 to it, we have to add it here at this position. So like this, if we keep adding the number at the right position to the sorted array, the array will be sorted all the time, and also we can return the kth smallest element. Right now the largest element is 5. Similarly, after adding 10, the large third largest element will be again 5. Like you can see in the output, after adding 9, so 9 will be added here. So the kth largest element will be 8 now. So here we can see. So like this we can maintain it, but this approach is brute force approach. We have to think of an optimal solution. In the brute force approach, the time complexity will be n log n, because we are going to sort the array, and also every time we are inserting the new element in the array, so we might have to shift the other elements to the right. In the worst case, it will be O of n. So the time complexity will be n log n plus n. So this is brute force approach. We should try to optimize this. So one possible solution you can get is using priority queue. Just listening to the question, we should get that intuition that we can use priority queue here, because they are asking kth largest element. So if we take the priority queue, let's initialize the priority queue. In a priority queue, the nums will be in sorted order. The element at the top will be the lowest element in the array. So 2 3, let's store this initial array in priority queue. 2 4 5 8, 2 4 5 8. 2, 4, 5, 8. So to get the kth largest element, we simply have to pop all the elements until the priority queue size is k. That is, as of now, here is 3. So, the least element, least element in the priority queue will be at the top. That is the kth largest element. So, to solve this problem, we have to store the nums in priority queue, and every time we add a number to this, we simply have to add it to the priority queue and simply pop the all elements and just keep the size as uh, k. So let me code this up here. So I hope you understood the intuition. So first of all, here we are going to define a priority queue, t queue of type integer. Also, you have to remember that every time we add a value, we just need the kth largest element. We do not, it is not necessary to keep all the elements. We simply have to return the kth largest one. That's why we'll be keeping only k elements in the priority queue. I am defining the priority queue and size k here in the constructor. Let me uh, initialize the this dot k to value of k, and also initialize the priority queue, pq equal to priority queue. Type will be, forgot to add a new keyword here, new priority queue. So we have initialized the priority queue. Now we simply have to add nums in numbers in nums array to the priority queue. Simply gonna call the function pq.add that simply pushes the nums into priority queue. And the next thing I said is, we since we only need to return the kth largest element, we can simply have the k elements in the priority queue. So the element at the top will be the required answer, the kth largest elements, because priority queue returns the least element in the array. So we have k elements, and the kth largest element will be at the top of the priority queue. So we have to pop all the elements in the priority queue such that the size of priority queue will be k. If the priority of the size of priority queue is greater than k, we simply going to return remove all the elements, all the least elements. So this is what we have to do in the initialization constructor. So in the add function, we have to simply add the number 2 value to the priority queue, and if priority queue size is greater than k, we just simply remove that element, remove the top element, and then, so if sorry if, if the size of priority queue is greater than k, we just simply return the topmost element, and the our kth largest element will be at the k priority queue's top position. Priority queue peak is a function to get the element at the top of the priority queue. So I hope this works. We got a compilation error. Okay. Priority queue symbol pq. Priority queue. So sorry, I just made a typing mistake. It was pq. Okay, now it should work. The test case is passed. Let me submit the answer. So the beats are almost 50%, so that's an optimal solution. So now let's analyze the time complexity and space complexity. So the space complexity will be O of k, because we have initialized a priority queue, and priority queue will always be having a size of k, because even if we add the nums to the priority queue, we will be removing them until the size is kept k. So the space complexity will be big O of big O of k. And the time complexity here is, so the addition and removal operation in a priority queue costs us log of n, where n is the size of the priority queue. So here the size of priority queue will be k, so the time complexity will be log of k. Also we're going to call add function to the priority queue. How many number of times? The number of times there is a number addition. So the k will be uh, n log k, because here there are n numbers in the nums array, and we are calling addition operation to the priority queue that many number of times. The time complexity will be O of n log k plus also here in the add function we're adding the value we are getting to the priority queue. So the next one will be, let's call it as m is the number of elements we are going to add to the array, and the operation will be log of k, addition operation or remove operation. This will be the time complexity of this algorithm, and space complexity is O of k. I hope you understood the question. Thank you.